Now, this is going to be a really interesting topic. If you're cutting a lot of holes in a production setting and a lot of hole patterns, you can get a drill block, which also referred to as a multi-drill head, set to this pattern that you need to machine. And we're going to show you how to set that part up and use the multi-drill block to machine the part that you see here. And as I mentioned, you can use it for machining multiple hole patterns to save you time on the CNC machine. And it supports all of the current drill operation types. This is going to be an interesting one.
Okay, let's moving on to our next topic. We're going to be talking about drill head programming, drill block programming, or also known as multi-drill head programming. What I'm going to be showing is an example of a 4 drill bit drill head, multi-drill head that I have. I'm going to show you the picture of what I have. And this is basically the picture of a depiction of what I have in terms of the multi-head drill block. So it's got 4 tools. Tool number 1, and this is tool number 2, tool number 3, and tool number 4. And this drill head, we can independently turn on or off any of these 4 drills. We can keep them all turned on, or depending on the cut pattern or the hole pattern that we have, I can turn on just a few. And we'll be talking about how we're going to be programming those the patterns that I showed you. Okay, so let's before we go on, I want to talk about the part file a little bit. Let me move. What I have on my screen is a Rhino file. This is a typical file that you might be machining with. This got a lot of hole patterns. This has got 4 hole patterns on the corners, and then there's 1 hole pattern in the middle. The hole pattern are all equally spaced holes. They're spaced by 0.25 inches. And as you can see, there are quite a few different configurations as far as the hole patterns are concerned. But they're all of the same size holes, same depth, and so I can conceivably use my multi-drill head to program these. Okay, let's talk a little bit about the concept of programming a multi-drill head. So in what you're really programming is a tool, just like you would program a single drill tool, but there is one preferred anchor position or tool, a number that you're programming, the tool position that you're programming. So looking back at the station here. So typically you would be programming this tool number 1 that's shown here, which is in the lower left corner of the drill block. And so that's the position you're going to be actually programming in terms of the actual drilling operation. But you will be turning on and off any one of the other tools, or even the tool 1. You can either turn that on or off. So how do we go about turning these off and on? And how do we control this in our CAM system? Before we get into that, I want to talk about a few concepts that we need to be clear on. One of the things is assignment of binary codes for each of these tools. So I have a table here that basically assigns a binary code for each of the tools. The tool number on the left, I have 8 tools listed. Potentially you could have a multi-drill head or a drill block that has 8 tools. In my case, I have 4 tools, but just for illustration, I've shown you 8 tools here, and the corresponding binary code for each of these tools. So for tool number 1, the binary code is 1. Tool number 2 is 2. Tool number 3, it's 4. Tool number 4 is 8, and so on. For those of you who are not familiar with binary codes are basically start with number 1, and the next binary number would be multiplied by 2. So 1 multiplied by 2 gives you 2. 2 times 2 gives you 4, 4 times 2 gives 8. So that's how the binary numbers are ordered. So that's the assignment. So for each of these tools, you're going to assign a binary code. And then just to turn on or off any of the tools, just to turn on the tools, not off, just to turn on the tools, you're going to add the binary codes associated with the tools that you want to turn on. So let's say you wanted to turn on tool numbers 1, 3, and 4. So what you're going to do is you're going to add up the binary codes of those 3 tools, which in this case would be 1, 4, and 8, and that gives us binary code 13, or a total of 13. And then we would create a single tool with that number 13 as the tool number, and that's the encoding step that we're doing next. So once we have that, we can program using that tool in this anchor position, or the tool number 1 position. And then when we output it, post-process it, the post processor will take the number that you have encoded in that particular tool and do the necessary decoding and output the corresponding G code for your controller. So let's go through that very quickly in this part file. Okay, so what I have here, let's talk about this pattern, whole pattern on the lower left corner. So here, if I employ my four drill head or 4 drill block, I need to turn off drill number 4 in this particular case, because I'm not there's nothing to drill on that location. So I would need to turn on 1, 2, and 3. The drills 1, 2, and 3 in my drill block. So what I need to do is I need to go back to my binary table and add the binary numbers associated with these tools, which would be 1, 2, and 4. So that gives me 7. And then I create a tool. It's tool number 7, which I've already done. Here I'm calling the LLC, half-inch LLC, which is lower left corner. And I've given it a tool number 7. I've programmed a tool, created a tool with tool number 7. And then I'm going to use that tool when I program this whole pattern, so which I've already done. I've taken my anchor hole and using that as the drill bit, a drill hole for the drill operation. I've created a drilling operation here using the lower left corner drill bit. So I really don't care about the depth at this point. This is just for illustration purposes. And now, even though I'm just programming the anchor bit, and since I'm using the drill tool, which has got the binary code encoded, when I create this tool path and output it using the correct tool path post processor, it'll be decoded correctly. So let me show you that. Just select this, and I have a post processor selected already. This is an example of our latest programmable post. For those of you who are not familiar with programmable posts, I'll talk about that in a minute. But this is very exciting development in our system since 2021, release 2021, which you can do quite a bit of logic using Python programming language. I'll show in a minute. But let's see how that post operates. So when I select this operation and I do a post process, you'll see that this particular tool, which I had tool number 7 encoded in it, is coming out as 1, 2, and 3. So we're turning on tools 1, 2, and 3 in my drill block when this gets output. So which is exactly what the pattern we want. To machine that pattern, we need tools 1, 2, and 3 output. So let's talk about the lower right corner. In this particular case, we have to turn on tools 1, 2, and 4. And 4 is the binary code 8. So 8 plus 2 is 10. 10 plus 1 is, gives us 11. So now I've already got a tool. Lower right corner, I'm calling it the LRC, and it's got 11. I got a tool number 11 encoded. And then I'm selecting this drill hole, and I've already created a drill operation with that tool selected. So when I post process this, you'll see the correct tools being turned on. So you'll see tools 1, 2, and 4 being turned on at the output level. So this is how you would program whole patterns. A couple of caveats. One is a whole pattern like this on the top right corner. Let's call it the upper right corner. What we have here is we have 3 holes, but the anchor hole is not being drilled. So the lower left corner is not being drilled. So even though it's not being drilled, we actually, in our CAM system, we have to create an operation that actually creates a drill operation there, or a drill toolpath that goes right there. So that's why I've created this circle to represent the location of the anchor bit, and I've created my drill operation to drill that hole. And then I'm using the URC drill bit that I've already created. So with the binary code for that would be the binary addition of 2, 3, and 4. And I believe that's 13, if I'm not mistaken. But that's 14. Okay, tool number 14. So if I post this, you will see 2, 3, and 4 being turned on. So that's even though only 2, 3, and 4 are turned on, even though we have programmed this anchor hole, this is not going to be machined. Only these 3 holes are going to be machined on your machine tool. Finally, one caveat about the patterns. We had repeating patterns, and if you have a pattern like this, the idea is you can look for repeating patterns. In this particular case, I noticed that the upper right 3 holes are very similar to these lower left corner pattern, so which means I can use the same tool, and same tool that I used for this lower left corner. So let's talk about that one. So I'm programming that hole, and I'm using the same tool that I use for the lower left corner. As you can see, it's selecting the lower left corner. So when I post process that, you should see 1, 2, and 3 turned on. So 1, 2, and 3 turned on. I guess the idea here is to look for repeating patterns and use the same tools for those repeating patterns. So that's something that you as a programmer need to be cognizant of. So let me go ahead and post the entire setup, and let's see how these numbers turn on. Okay, here we go. So the first operation, we got T1, 2, and 3 turned on. Second one, which is this pattern, is 1, 2, and 4. 1, 3, and 4, I believe, is for this. 2, 3, and 4 is for that one. And then 1, 2, and 3, which is similar. This is the similar patterns, the lower left corner. And then you have the 2, 2, and 3, which is just these 2 holes, 2 and 3 being machined. And finally, T0 in this particular controller at T0, when you employ a T0 code, it'll basically retract all the drill bits, and you're not machining anything at that point. So that's all drill bits are up at that point, and you typically do it at the end or at the beginning before you actually engage any of the tools.